Hello, I'm Miss Liz with the Cincinnati Symphony Orchestra Sound Discoveries program, and I have a question for you. Can you hear me right now? Can you hear the sound of my voice? Oh, good. But how does the sound of my voice get from here to there? What is sound and how does it travel? That's what we're going to take a look at today. Sound is vibration, which is when something moves really quickly. What are some sounds that you can think of? If you started making a list of all the sounds in the world, you would never stop writing. Sounds are everywhere. Sometimes I like to close my eyes and just see what kind of sounds I can notice. It's really relaxing. Let's try this. We are going to stay as still and as silent as we can for 1 minute, close our eyes, and see what we can hear. What sounds do you notice when you close your eyes? How does sound travel? Sound travels in a wave, but not this kind of wave, or this. Sound travels in something called a longitudinal wave, also sometimes referred to as a pressure wave or compression wave. Can you say longitudinal? Longitudinal. Let's try a little experiment to get a visual idea of how sound moves. All you need is a slinky. We tried this in our Sound Discoveries class and it worked great. In this experiment, 2 people will hold an end of the slinky and stretch it out until it makes a straight line. Then, one person will tap gently on the end of the slinky. The energy from that movement will transfer through each metal ring in the slinky until it reaches the end, and then it will transfer back the same way. You can actually see the wave move back and forth. Pretty cool, right? Here's another way to create a visual model for how sound moves. All we need are some dominoes. We are going to set the dominoes up in a line about 1 inch apart. While I'm setting these up, I'd like you to get out your log. I don't mean a fallen tree, I mean a journal where you can record your scientific ideas and observations. If you don't have a notebook, a piece of paper and pen or pencil will work. Now we are going to start with our scientific process. Let's start with a question. Please write this down at the top of your page. What will happen when we knock over the first domino in the line? We already gathered some information and made some observations when we watched what happened with the slinky. Now we are going to make a hypothesis or a guess about what will happen with the dominoes. Can you say hypothesis? Hypothesis. Let's record our guesses in our log. Whatever you think will happen when I knock over the first domino, go ahead and write it down. Or if a family member or a teacher is keeping track of all the guesses, go ahead and tell them your guess. Now that we have a hypothesis, we are going to test it by performing the experiment. Let's see what happens when I knock over the first domino. Here we go. Wow! So let's see this again in slow motion. The first domino knocked over the second domino in line, which knocked over the next one, and the next one all the way to the end. The energy transferred and passed through each item. Let's take a moment and write down our results. As you do so, compare the outcome with your hypothesis. Were the results what you expected? Why or why not? Either way, it's interesting. This is how sound moves. The original vibration that is created vibrates particles, which in turn vibrate the particles next to them, and so on. This energy moves in the same direction as the source vibration, which is why if we're talking, it's easier to hear my voice, the sound is louder if I'm facing you rather than if I turn away. The farther a sound moves from its source, the less energy there will be in the vibrations, until eventually there is not enough energy to vibrate anything and the sound dies out. This is similar to throwing a stone in a pool. The ripples will continue outward until eventually they are no longer visible. What would happen if there was nothing to vibrate, no air or other objects? Would you hear a sound? What do you think? Let's think back to our dominoes. If I pushed over just one domino and there were no other dominoes, could that energy travel? No. A vibration cannot travel if there's nothing for it to pass through. Because of this, in a vacuum where there is no matter, there is no sound. You might have heard this saying, if a tree falls in the woods and no one is there to hear it, does it make a sound? Based on what we've discovered today, I would have to say yes. The energy of the tree crashing to the ground would still vibrate the air particles and create a sound, even if we weren't there to hear it. In fact, this probably happens all the time. Maybe it's happening right now. When you think about things, it gets deep. This is what scientists do all the time. They wonder about the world around them, and then they make guesses as to what's happening. Then they try to figure it out. We can all be scientists in our lives. All we need is to be curious. Now it's time for our DIY project, something for you to try on your own. You will need a partner and a tape measure. First, let's grab our logbooks and write down this question. At what distance will the sound of my voice dissipate or fade out? You can write 50 feet, 100 feet, whatever you guess. A big space works best, so you'll probably want to head outside. Your job is going to be to sing the alphabet song continuously and consistently. Continuous means you'll keep singing and singing until you're asked to stop. Consistent means you'll keep the same volume level and not get louder or softer because this could affect the experiment. Meanwhile, your partner will take the tape measure and walk away slowly until they can no longer hear your voice. They'll walk back and forth until they can find the exact point at which your voice disappears for them. Both of you will write this number down and then trade places. And so now you can walk away slowly with the tape measure and find the exact point at which you can no longer hear their voice. Then compare the two numbers. Are they similar? Are they different? Why or why not? You can write down all your ideas in your log. Thank you so much for joining me today in exploring the science of sound. I'm Miss Liz with the Cincinnati Symphony Orchestra's Sound Discoveries program. See you soon!